Dr. R. Hemavati is an assistant professor in mathematics in Queen Mary's, Chennai. She has specialized on functional analysis. Having 12 years of experience in teaching, she has won various awards for her performance. She has published papers in 14 international journals, 3 national journals, and has presented papers in 10 international and in 5 national conferences. She is also one of the editors for an international journal.
Welcome to UGC lecture series. In the early sessions, we were talking about a test of significance, that is, we have discussed large sample test and small sample test. In continuance with the small sample test, we were discussing t-test for testing mean and f-test for testing difference of variances, whereas we have also discussed the procedure for testing single variance with chi-square test. In this session, continuing with the discussion of test of significance, chi-square test for testing single variance problems will be worked out, and also the testing the goodness of fit of various distributions will be discussed with respect to chi-square test. So, objective of this session is to work out some problems in chi-square test for testing single variance and for testing the goodness of fit of various distributions. Actually, the goodness of fit testing plays a very important role when you are drawing inference with respect to a case study. This tables of chi-square distribution will be used when you are working out the problems to take the table values. So, this is the problem. After working out 30 examples, this is 31st example. Over the years, the grades in a mathematics professor's calculus classes have been normally distributed with mean 75 and standard deviation 8. Recently, the grades seem to have fallen and show more variation. A sample of 41 recent grades, this is the sample size, has mean 73 and standard deviation 9.6. Test whether the population variance is greater than 64. Now, this particular sample size 41 is above 30, and therefore, it comes under large sample test. Therefore, the test of significance, that is the random sample, have normally distributed population, that is it is following normal distribution. Okay, we will work out this problem taking all the values. So, you are asked to verify whether the population variance is greater than 64. So, therefore, only one kind of sample has been given, that is a sample of 41 grades of the mathematics professor's calculus classes, and you are asked to test whether it is greater than 64. Therefore, this is a single variance test. So, that is the identification. Therefore, we first of all take out the values given in the question. N is equal to 41, it's moreover it is a large sample, and x bar is equal to 73 and standard deviation is equal to 9.6, and also the population mean is given. Population mean is 75 and population standard deviation sigma is equal to 8. We will go ahead with testing the single variance using chi-square test. So, this is chi-square test for single variance. The procedure has been already discussed in the previous session. Therefore, we will start up the with the H naught. H naught is actually null hypothesis. H naught is setting up the population variance values in the H naught. So, what is your population variance? Population variance is 8 square, because population standard deviation is 8. Therefore, population variance will be 8 square, which is equal to 64. That is, we take the H naught value as population variance is 64. Then, in particular, the question is asked to verify whether population variance is greater than 64. So, specified it is a one-tailed test. So, sigma square will be definitely greater than 64, not equal to possibility and lesser possibility is ruled out. Therefore, it is a one-tailed test. okay. And then step 3 says the level of significance. In words, actually here we take a population variance is greater than 64, and in step 3 we fix up the level of significance at 5%, and degrees of freedom is k minus 1. So 41 minus 1 is 40. Chi-square is equal to n minus 1 into s square by sigma square. N is 41. So 41 minus 1 into what is s square value? S square is 9.6. So s is 9.6, therefore 9.6 whole square by sigma square is 8 square, and this value comes to be equal to 57.6. So now we have come to the comparison part, where calculated chi-square at 5% comma 40 degrees of freedom is equal to 57.6, whereas tabulated chi-square at 5% comma 40 degrees of freedom is equal to, we have to look into the tables for 40 degrees of freedom and 5% level of significance is 26.51, isn't it? This is 5% level of significance and 40 degrees of freedom, 26.51. Actually, one more discussion has to be done, that is this is actually one-tailed test. The problem we are discussing is one-tailed test, and this particular chi-square value is given for a two-tailed test. Therefore, we have to take 0.025 values, that is 0.05 is there. For one-tailed conversion we have to divide it by 2. Therefore, calculated value will be for the corresponding degrees of freedom 40 is 26.15. This is from the tables. Already the table values are given for one-tailed test. Now the calculated value is 57.6 is much greater than 26.15. Therefore, calculated value is greater than tabulated value, which means H naught is rejected. H naught is rejected in the sense when H1 is accepted, what is the conclusion? We have set up in H1 that population variance is greater than 64. So, population variance is greater than 64. That is the ultimate conclusion for this problem. Next, when the values are not given directly to you, you have to calculate it using the sample values given in the question. So, this problem goes like the number of eggs produced annually by individual chicken hens on old McDonald's farm is normally distributed with mean 250 and standard deviation 15. The number of eggs produced by 6 randomly chosen hens given a new feed was 260, 240, 270, 250, 265 and 245. Test whether the standard deviation is less than or equal to 15. Even testing the single standard deviation also can be done with the chi-square test. Like testing the single variance is done with the chi-square test because variance is actually standard deviation square. Therefore, testing the single standard deviation for the small sample case can be done with the chi-square test. Whereas we have discussed already in large sample Z test for single standard deviation, where the Z formula stands for S minus sigma divided by root of sigma by 2n. That problems we have already discussed in large sample when the sample size is greater than or equal to 30. Now, this is a small sample of 6 and you are asked to test whether the standard deviation is less than or equal to 15, again a one-tailed case. Therefore, we have to use a chi-square test for single variance. What are the values given in the question? Mu is equal to population mean is equal to 250 and population standard deviation is equal to 15, and sample values are given, n is equal to 6 and sample values are 260, 240 like that. We have to calculate x bar if you want, and then s square. Okay. The formula for the chi-square when the population is normally distributed. Here you have given population is normally distributed. Therefore, the formula for chi-square when the population is normally distributed is discussed in the previous session as chi-square is equal to summation xi minus mu whole square by sigma square. Okay, so let us go ahead with the procedure of test of significance, where in H naught we fix up usually variance value. Since you are asked to test the standard deviation, H naught will be testing the standard deviation value. So, sigma is equal to 15, that is population SD standard deviation is 15 against H1 specifically asked in the question to check whether it is less than or equal to 15. So, population SD is less than 15. So, it is one tailed alternative, therefore, one tailed test. Okay. And step 3 is level of significance 5% and the degrees of freedom is equal to k minus 1, k is here 6 minus 1 is equal to 5. And step 4 is actual calculation part. Step 4 is chi-square is equal to summation xi minus mu whole square by sigma square, where xi values are 260, 240, 270, 250 like that. So, 260, 240, 270, 250, 260 and then 245. Xi minus mu values is xi minus 250 values. So, 10 minus 10, 20, 0, 10 and then minus 5. Then this is xi minus mu whole square 100, 100, 400, 0, 100 and 25, and this is summation xi minus mu whole square is equal to 725, summation xi minus mu whole square. Okay. Now, the chi-square value, chi-square is summation xi minus mu whole square by sigma square is 725 by 15 square, and this value comes to be equal to 3.78. Now, we have come to the comparison part. So, the calculated value of chi-square at 5% 5 degrees of freedom is 3.78 and tabulated chi-square at 5% 5 degrees of freedom is 1.15. Since calculated value is much greater than tabulated value, H naught is rejected. In the sense H1 is accepted, we say that the population SD standard deviation is less than or equal to 15. That is the conclusion. Now, after discussing the test of significance for testing single variance, next we shall discuss chi-square test for goodness of fit. After testing the test chi-square test for single variance, in continuance with the talk of chi-square test, chi-square test also will be used for testing the goodness of fit of various distributions. Discrete distributions and continuous distributions already we have discussed in statistical methods 1. Discrete distributions discussed were binomial, Poisson, normal. All those distributions can be verified whether they can fit into the data given using this chi-square test for goodness of fit. First of all, we will start with discussing the fit of uniform distribution or the equal distribution. So, the procedure for the chi-square test for goodness of fit is the usual procedure, but here the setting up of H naught only will vary. Usual procedure of step 1 null hypothesis and step 2 alternative hypothesis, step 3 level of significance, degrees of freedom, and then step 4 computation part, step 5 is conclusion part. Whereas here we set summation observed frequency is equal to summation expected frequency. That is, in H naught we set up the distribution taken into account as is a good fit. The distribution is a good fit. That is the assumption we are making according to the null hypothesis. Whereas in step 2 we set up H1 as a summation OI is not equal to summation EI, where we say that the distribution is not a good fit. Not a good fit. And step 3 is usual level of significance and degrees of freedom part, and step 4 is the calculation of first EI, because the frequencies given in the question will be called as observed frequencies. Expected frequencies are the frequencies which we are calculating using the distributions given in to fit, right. So, the calculation of EI using the distributions of fit, okay. And then we calculate the chi-square part. Chi-square part is calculated using this tabular column. First of all, you have to list out OI values which is given in the question. Then you list out EI values which you have calculated. When these two columns are formed, we have to check whether summation OI is equal to summation EI. Then only corresponding calculations will be correct, or we have taken H naught as summation OI is equal to summation EI will be correct. Okay. Then you form the tabular column OI minus EI, then next form the column OI minus EI whole square, then next you form the column OI minus EI whole square by EI. This particular last column summation will be called as summation OI minus EI whole square by EI, which is the formula for chi-square. So, you do not take the values from the tabular column and then you substitute in the formula and then calculate chi-square. Directly the last column of the table of calculation for chi-square, the last column summation gives you the corresponding calculated chi-square for the corresponding degrees of freedom. Then step 5 usual part, step 5 is the comparison and then calculated value, comparison and then conclusion. So, whether calculated value is less than tabulated value H naught is accepted, that is usual thing, okay. And if it is otherwise greater than, then H naught is rejected. Okay, this problem says that a company keeps records of accidents. During a recent safety review, a random sample of 60 accidents was selected and is classified by the day of the week on which they occurred as follows. In a particular week it was calculated, and then Monday 8 accidents had happened, Tuesday 12 accidents, like that Wednesday 9, Thursday 14 and Friday 17 accidents. Test whether there is any evidence that the accidents are more likely on some days than others. It means whether the accidents are equally distributed over the week. This we have to test, and this particular case has been studied using chi-square test. First of all, we will start up with identification. Since we are talking about the frequency, testing the frequency and testing the goodness of a fit of likely distribution or equal distribution can be done with only chi-square. So, whenever you are asked to test the frequency, use chi-square test for goodness of fit. Okay. So, step 1 says H naught such that summation OI is equal to summation EI, that is the likely distribution or equal distribution is a good fit. Is a good fit, okay. Or according to the question, accidents are more likely, accidents are more likely, it means that they are equally distributed. Step 2 says that H1 is such that sigma OI is not equal to sigma EI, that is we say that accidents are not likely. Step 3 is level of significance 5%, and the degrees of freedom varies according to distributions. For equal distribution and binomial distribution, it is n minus 1. N stands for the number of categories. Here Monday, Tuesday, Wednesday, Thursday, Friday, up to only Friday has been taken. Therefore, the number of categories is 5. So, that kind of category is n here, that is n minus 1 for equal and binomial distribution, whereas for Poisson distribution it is n minus 2. N minus 2 in the sense 1 degree of freedom will be lost, actually n only, 1 degree of freedom will be lost when you are calculating chi-square, and another degree of freedom will be lost in case of Poisson distribution for calculating the average. That type of problems we will be working out in the future sessions. And then for normal distribution it is n minus 3, because 1 degree of freedom is lost for calculating chi-square, 1 is lost for calculating the population mean mu, and another one will be lost for calculating standard deviation sigma. Okay, so the degrees of freedom here is the number of categories 5. So, 5 minus 1 is equal to 4. So, the step 4 is calculation part where we have to calculate the OI and EI, OI minus EI, and then chi-square value. These are the OI values which are given in the question, right? That is the observed frequencies. On Monday 8 accidents, then 12, 9, 14 and 17. Then EI, when you calculate OI's total, it comes to be equal to summation OI is equal to 60. Now, this particular 60 has to be distributed for 5 days, Monday, Tuesday, Wednesday, Thursday and Friday. How it is equally distributed? 60 divided by 5 is equal to 12. So, that 12 is equally or likely distributed as 12, 12, 12, 12 etc. for the 5 days. This is what the equal distribution says, calculation of EI for equally distributed days in the particular weeks. So, that is 12, 12, 12, 12, and this particular summation also comes to be equal to 60. This is what you should always verify, summation OI should be equal to summation EI. The next column is OI minus EI, that is 8 minus 12 is minus 4, 12 minus 12 0, like that this column is formed. Then next OI minus EI whole square, this particular column OI minus EI is a square. So, minus 4 square is 16, like that this column is formed. Then this column is OI minus EI whole square by EI, that is OI minus EI whole square is 16 divided by 12. So, this particular value is 16 by 12, this is 1.33. Similarly, 0 by 12 is 0, like that this particular column is formed, and this column total is summation OI minus EI whole square by EI, and this summation value comes to be equal to 4.493. Okay. After the calculation of chi-square, now we have come to the comparison part, where calculated chi-square at 5% level of significance, 4 degrees of freedom is just calculated as 4.493, and then tabulated chi-square at 5%, 4 degrees of freedom is equal to 9.488, which is from the tables, and then since a calculated value is less than tabulated value, H naught is accepted. Now, H naught is accepted in the sense the accidents are more likely on some days than others. In this session, some problems have been worked out in chi-square test for testing single variance, and then a goodness of fit procedure has been discussed, and we have also worked out a problem testing the goodness of fit of equal distribution using Chisquare test. So, based on the discussion in this session, this following questions may be posed. The number of hours spent reading by an undergraduate college student is a normal random variable with mean 7.5 and variance 1.25. In graduate school, the student reading pattern changes. A sample of 15 days gives an average of 6.25 hours and variance 1.5. Test the hypothesis that the population variance is 1.25. Only one kind of sample has been given, therefore, you have to use a Chisquare test for single variance. Then this particular problem is about the number of road accidents in 10 weeks period. The number of road accidents in 10 weeks periods in a certain area were as follows: 12, 8, 20, 2, 4, 14, 10, 15, 6, 9. Are these frequencies in agreement with the belief that the number of road accidents are uniformly distributed during the 10 weeks period? So, you have to use the uniform distribution is nothing but equal distribution. Just sum up these number of accidents and accordingly distribute it for 10 weeks, that is the total sum divided by 10 will give you the equally distributed values for 10 weeks. Use equal distribution and test whether equal distribution is a good fit using a Chisquare distribution. Thank you.